Hi, my name is Miriam Lopez. I will be working on problem 13 from chapter 13 for my final exam presentation. So problem 13 from chapter 14 says, Sprouts, or a slight variation of it, is a game for two players. Any number of vertices are marked in the plane. Then the two players take turns to add a new vertex and to join it by the edges to two existing vertices. The only conditions are that the resulting picture must be a planar representation of a graph and that no vertex has degree more than 3. The loser is the first player who is unable to complete his or her turn. Show that regardless of the number of initial vertices, the game must come to an end. So we begin. You can start with however many points. I'm just going to start with 3. So we begin with 3 points. We have player 1 and player 2. You have 2 players. So I'm going to use 2 different colors, one for each player. So player 1 is going to begin, and he connects 2 of the vertices, and then he adds 1 more vertex. Then player 2 connects 2 of the existing vertices and adds 1 more vertex. So now this vertex right here has degree of 3 because it has 3 edges connected to it. So that one cannot be connected to anything else. So now player 2 continues, and player 2, we're going to say player 2 connects player 1 connects those. This one has a degree of 3, so that one cannot be connected to anything else. Player 2 continues with, we're going to say he connects this one. That one cannot be connected to anything else, and he adds 1 more vertex. So every single time, they keep adding a vertex until the game comes to an end. So now, player 1 can't connect this one to anything else. All the other vertices already have degree of 3, and there's no more vertices. So there's just 1 vertex. Even if there was another vertex, if it's on this line, it can't cross the other edges because it has to be planar. However, if that was not one of the requirements, this game would still come to an end. So since I have to prove that regardless of the number of the initial vertices, the game must come to an end, I came up with a formula. And my formula is that the sum of the vertices in G sub R are equal to the sum of the vertices in G sub R plus 1 plus 4 less than or equal to 3n plus 1. So before I begin, V is equal, so the number of vertices is going to be equal to n. And then G sub R is the graph at turn R. So I'm going to prove how this works. So if we begin at turn 0, so I'm gonna do like 2 turns just so you can see how this works. At turn 0, and this time I'm just gonna start with 2 vertices because remember it can be with an infinite number of vertices. It doesn't matter how many vertices you begin with. So I have 2 vertices. Then the number of vertices is equal to 2. The number of edges, there are no edges, nothing's connected, so it's 0. And the number of degrees is also 0 because nothing's connected. So then we're going to go on to, before I go on to turn 1. So this formula is going to be the sum of degrees of V in turn 0, so G sub 0 is equal to the sum of the degrees in G actually this one's just 0. This is going to be for turn 1. I'll fix it. I just messed everything up. Let me just keep going. Turn 1. So turn 1, you have the 2 vertices. Player 1 connects the 2. Adds a vertex. So now we have 3 vertices, because now we have 3 dots. 3 vertices. We have 2 edges, and the degrees increase as well. So now this vertex has 1 degree. This vertex has 2 degrees, and this vertex has 1 degree. So it's a total of 1, 2, 3, 4. So now, if we use the formula, we have, this is turn 1. So if we use the formula, we have the sum of the degrees in G sub 1, because this is the first turn, is equal to the sum of the degrees of G sub 0. So what basically happened is the degrees increased by 4. So we're going to say plus 4, because we're adding 4 to the number of degrees in turn 0. And this is going to be less than or equal to 3 times n plus 1. Well, now our n, remember our n is the number of vertices. Our n is 3. So 3 plus 1, which is basically 3 plus 1 is 4. 4 times 3 is 12. And then this is going to become the sum of the degrees from 0. Well, in turn 0, we had 0 degrees. So this is basically 0 plus 4 less than or equal to 12. So this is what we're going to focus on right here. So now if I go to turn 2, I have the 2 dots, the move that player 1 did. Now player 2 is going to do a move. So now we're going to say player 2 connects these 2 and adds a dot, adds a vertex, and that vertex is done. So now the number of vertices goes to 4. The number of edges, we have 1, 2, 3, 4 edges. The number of degrees is 1, 2, 3, 4, 5, 6, 7, 8. So now our formula is going to look like this. The sum of the degrees, and this is now turn 2, so it's going to be V in G sub 2, which is equal to the sum of the degrees in V in G sub 1 plus 4 less than or equal to 3 times. So remember, we have a total of 4 vertices, so this is 4 plus 1 is equal to 4 plus 1 is 5. 5 times 3 is 15. The sum of the degrees in turn 1 was 4. So now this is 4 plus 4 less than or equal to 15. 4 plus 4 is 8 less than or equal to 15. So as you can see, within just these two turns, the vertices are going up and the vertices are going up. So this one was from 4 to 12. So 12 is basically the missing edges. So 4 is 8 edges away from 12. 8 is 7 edges away from 5. So this is 8 missing edges. And this one is 7 missing edges. So every single time, after every single turn, the edges will decrease by 1. So these two numbers will eventually get closer and closer and closer together, that there will not be, one of the players will not be able to put or connect the two vertices. So to prove how we can also prove with this formula the amount of moves that one person can make according to the number of vertices that they began with. So let me give you an example of that. So again, this is our proof. So again, my formula is V and G sub R is the sum of degrees is equal to the sum of degrees in G sub R plus 1. So the next move, plus 4 is less than or equal to 3n plus 1. So how this works is we're trying to figure out, we're trying to prove that this is eventually going to come to an end. So we're going to solve for the degrees of the next move of G sub R plus 1. So we subtract 4. Let me use another color. We subtract 4 because we're solving for this. So now that cancels out. So we have the sum of the degrees less than or equal to 3, and this, by the way, there's parentheses there, so this is 3n plus 3 minus 4. Which becomes 3 minus 4 is -1, so we have 3n minus 1. So if, for example, we have a game that starts off with 3 points, 3 vertices, so this is an example. That means if we plug the vertices in there, n for n, (3 times 3 minus 1), we know 3 times 3 is 9, 9 minus 1 is 8. So there will be less than or equal to 8 moves before this game finishes. So just to show you, I'm just gonna do a quick, it's basically the same when we started earlier. So we start with 3 points. So this is 1 move. I'm just gonna do it with the same color, but it's 2 players. So that's 1 move, 2, 3, 4, 5, 6, 7, 8, and this one can actually connect with this one, gives us 8 moves. and this one cannot connect to anything else. So this one was a total of 8 moves. Of course, it can be less than that. If somebody blocks them, if one of the players blocks the other players, there can only be 8 moves. So with this formula, we can prove that the game will eventually come to an end, and we can actually prove with how many moves or less, because the number of edges are eventually decreasing by 1, so that's where the -1 comes in. The number of edges are decreasing by 1 every single time. I hope this made sense, and I tried it with different points, and it worked with all of them.